Imagine, imagine a car moving with velocity v. This is the car moving with velocity. The car is here. It's moving with this velocity. Suddenly, the car takes the curve and he's moving with the same magnitude of the velocity, the same speed, but in a different direction. So now you move in this direction and the amount of velocity is exactly the same one. So the new velocity v final is this one. So this is v initial and v final. And the problem is the car velocity changing? Of course. At the beginning it was in this direction, and now it's in this direction. So it's changing, and the change in the velocity is here. This is the change in the velocity. So what you have learned that when you make the difference between A and C, so the difference C minus A is this vector, is the vector that goes from the head of A to the head of C. This is the change in the vector. In what vector? In the vector A. The vector A plus the change in the vector A is equal to the vector C. Okay, let's go to other questions. The graph shows, so this question was solved in class, and it say this is the graph, this is the position x versus time t, and the position is going further and further and further, and the question is, does the car ever go backward? Backward, no U-turn. So now the position is approaching, so this is the observer. The observer see the car here, let's say, so he see the car here, later on he see the car here, so he see the car moving in this direction. After he arrived to this point, he see the car coming back. Then after this point, his position is like this, and like this. You see, he's approaching, he's moving in this direction. So yes, after this point, the car is coming back. The observer, this observer will see the car going farther on the first steps, on the first two steps, and after this point, the observer will see the car coming back in this direction, coming back. Let's do another question. Is the instantaneous velocity at point A greater than at point B? We see that this is a graph of x versus t. And we saw in class that the velocity is related with the slope of the curve. And the slope is bigger in A than in V. So the slope around V is smaller. So is the instantaneous velocity at point A greater? Yes, at point A is greater because the slope is greater. Let's go to the next question. This question says, in the graph shown, is the velocity constant for any time interval? Well, I see that the velocity, let's say that is 100 meters per second, so 100, and 100. So between 0 and 2, I see a velocity that is constant. So the correct answer should be A. Let's go to the next question. Now it's in this graph, in the graph that you see, that is velocity versus time. Remember, this is velocity, what you see. Here we saw that the velocity is constant, is between 0 and 2 is 100. After 2, the velocity increase and increase. So the questions say, during which time interval is the acceleration greatest? I see that the velocity increase greatest between 2 and 4. Between 2 and 4, the velocity is increasing. After 4, the velocity is smaller, is decreasing. So on the range of 2 and 4, the acceleration, because the acceleration is the change in velocity per unit of time. The change in velocity is big between 2 and 4. Okay, so let's go to the next question. Now it's a car moves a straight road as shown in the velocity graph. So you have to pay attention that this is velocity. Does it ever go backward? Assume no U-turn. So the velocity is positive here and big. The velocity is bigger here and positive. So it means that the particle, the car, is moving in the positive direction. The velocity is positive. It means that he's moving in the positive direction. He means that he's moving at C, he's moving in the positive, he's always moving in the positive direction. So does it ever go backward? No. This is your car. You are traveling. Let's say the two numbers here at A, let's say 50, here 100. So you are traveling at this time T, you are traveling at 50 meters per second. Later on at 100, you maintain velocity at 100. You maintain the positive direction always because the velocity is positive. When the velocity becomes negative is when you are coming back. And when the velocity will come back, well, if you extend the curve like this and the time like this, after this point the velocity will be negative. And this will mean that after this time, maybe 8 seconds, maybe 8, you are coming back. But on the graph shown, there is, let's go to erase the graph. On the graph shown, there is no turning back point. So let's go to the next question. In which point the magnitude of the acceleration is greatest? The acceleration is the change in velocity per unit of time. So when the change in the velocity is big, the acceleration is big. So you see that the space in time are always 2 seconds. There are 2 seconds here, 2 seconds in this section, and from 4 to 6 there are 2 seconds. So because delta t is 2 seconds in each section, for the point A, the acceleration is the change in velocity divided by the time. Let's say that this is 100 here, 100. So the velocity increase from 0 until 100. What is the acceleration between t 0 and 2? The acceleration is the change in velocity, 100 minus 0. V final minus V initial, divided by 2. So the acceleration will be 50. If this is meter per second, will be meters per second squared. Okay, between 2 and 4, between 2 and 4, between 2 and 4, the acceleration is again the change in velocity. But at the point B, around the point V, the change in velocity, there is no change because V final is 100 and V initial is 100 on this interval of time. Divide by 2, 0 divided by 2 is 0. So it means that the acceleration in this interval of time is 0. There is no change in velocity. And for the third part, at the point C, the acceleration is negative. I don't know what's the amount of acceleration, but I can imagine. Let's go to extend this like this, and let's go to suppose that this time from 4 to this point, let's say this is 8, is 4 seconds. So the amount of the acceleration will be the change in velocity per unit of time. What is the change in velocity? V final. Here, the velocity is 0. You see there is no velocity. V final is 0 minus V initial is 100 divided by delta t now is 4 seconds. Between 4 seconds and 8 seconds there are a time elapsed delta t of 4 seconds. So the acceleration is minus 25 meters per second squared. In any case, this is the winner. This is the greatest acceleration. Let's go to the next question. During which time interval between 0 and 2, 2 and 4, or 4 and 6 is the travel by the car the greatest? Means that the displacement is the greatest. Well, if he has a big velocity, he can displace a lot. But here, the velocity is changing, is becoming bigger and bigger and bigger. And we saw that the displacement, delta x, is v by delta t, because v is delta x divided by delta t. So if the displacement is v by delta t, and v by delta t, you see v by delta t, if you take a small time delta t, v by delta t is the area. So the displacement is bigger when the area is bigger. So we see which area is bigger. This one, or this one. The area bigger is between 2 and 4. So the displacement is bigger between t equal 2 and t equal 4. And this is the answer. Let's go to the next question. The velocity of the graph of a car is shown is the acceleration of the object constant. So what it means that this is the velocity, and the velocity is changing. But the change in the velocity, here is the change in the velocity. This amount. So V initial, let's go to do it better. Let's go to erase here. Let's say V initial, and let's say here V final. V final. There is acceleration, yes. Why? Because there is a change in the velocity. So the acceleration is the amount of the acceleration between these 2 points. This point A and B is the amount of the change, let's put it number 50 or 20 and 100 and 100. So the acceleration, average acceleration, is 100 minus 20, and let's put the numbers 2 and 10. Divide by the change in time, 2 seconds, 10 seconds, 8 seconds. So the acceleration will be 80 divided by 8. So, but the question is not like this. The question is say, okay, there is an acceleration, but is a constant acceleration? For a constant acceleration, the slope is constant. So the graph should be like this, a rectilinear line. In this graph, the acceleration is changing and it's becoming smaller and smaller and smaller. And if you continue the graph like this, you see that V final and the other V final, it will not have any change in velocity during during this interval of time, and the acceleration will be zero. So the acceleration start to be very big at the beginning, at t equals 0, very big, and the acceleration is becoming smaller and smaller, and 0 later on. Here is 0, the acceleration is 0. So is the acceleration of the object constant? No. To be constant the acceleration, you need a graph of v versus t that is a rectilinear line. Let's go to the next question. So this problem say this is v versus t. V versus t. The velocity is changing, it's a rectilinear line, so acceleration is constant. And what it's asking is, what is the average acceleration between 0 and 4? Between 0 and 4, the average acceleration is the change in the velocity divided by the change in time. What is the change in the velocity? I see here v final 4 meters per second. 4 meters per second is the vertical amount of velocity at t equals 4. V final minus V initial. V initial is 0. Here I don't see any V initial at t equals 0. Divided by t final, 4 minus 0. 4 minus 0 is 4. 4 divided by 4 is 1. 1 meter per second square is the acceleration of the body between 0 and 4. Okay, let's go to the next question. Now, the next question is exactly the same one, only that it asks you the average acceleration between 4 and 5. Let's say that at v initial at t equals 4 is 4 meters per second, and v final, this is at t equals 4, at t equals 5 seconds, the v final I see is 12 meters per second. What is the average acceleration? Is the change in velocity per unit of time. The change in velocity, 12 minus 4. The change in time, 5 minus 4. 12 minus 4, 8. 5 minus 4, 1. So the acceleration, A, is 8 meters per second square. So this is the correct answer. Okay. Let's go to the next one. Now it asks you the same question, but the time interval is between 0 and 5. It means that the curve is like this one, is this one. So this is V, this is T, so you will do the same equation, A equals delta V divided by delta T, but in the interval from 0 seconds to 5 seconds. V final minus V initial divided by T final minus T initial. What is V final? V final is 12. So it will be V final 12 minus V initial 0 divided by T final 5. V initial 0. So the average acceleration is 12 divided by 5 meters per second square. 12 divided by 5 is like 2 point something. So should be the C. Okay, should be the C, I suppose. Let's go to the next one. No, there is no next one. So I hope this summary will help you to redo it.